The story of Earth is one of dramatic transformations, cycles of birth and destruction, and the astonishing interplay between natural forces that have shaped our planet over billions of years. From the formation of Earth more than 4.5 billion years ago, through its turbulent early years, to the diverse and dynamic world we live in today, Earth's history is a tale of constant change, evolution, and survival. In the beginning, our planet did not exist as the vibrant, life-sustaining world we know now. It began as a molten, fiery mass, a swirling disk of gas and dust left over from the birth of the Sun. This disk of material, known as the solar nebula, slowly started to coalesce due to gravity, pulling particles together and forming the earliest building blocks of the planets. Over time, these chunks of rock and metal collided and merged, growing larger and larger, until they formed planetesimals, precursors to planets. As these planetesimals continued to collide, Earth's mass grew, and with it, its gravitational pull. Eventually, the young Earth took shape, a hot, molten sphere that was constantly bombarded by other planetesimals and asteroids. These violent collisions added more material to the growing planet and generated immense heat, keeping Earth's surface in a molten state. During this period, known as the Hadean Aeon, named after Hades, the Greek god of the underworld, Earth was a hellish, chaotic world, its surface a seething ocean of magma, with temperatures so high that no solid crust could form. But even in this early chaos, the seeds of the planet we know today were being sown. Slowly, Earth began to cool. As it did, heavier elements like iron and nickel sank toward the center, forming the planet's core, while lighter elements rose to the surface. This process of differentiation gave Earth its layered structure, a solid inner core, a liquid outer core, a viscous mantle, and a thin, rocky crust. The formation of the core also generated Earth's magnetic field, which would later protect the planet from harmful solar radiation and help make life possible. As Earth's surface cooled, solid rock began to form, and the first primitive crust appeared. Around the same time, a massive object, possibly the size of Mars, collided with Earth. This cataclysmic impact ejected a huge amount of debris into space, which eventually coalesced to form the Moon. The presence of the Moon would have profound effects on Earth's future, influencing everything from the planet's climate and tides to its axial stability. With a solid crust in place, Earth was still far from the life-sustaining planet we know today. The atmosphere during the Hadean Aeon was vastly different from the one we breathe now. It consisted primarily of hydrogen and helium, but these light gases were gradually lost to space due to solar winds. As volcanic activity increased, gases like carbon dioxide, water vapor, methane, and ammonia were released from the planet's interior, forming a new, thicker atmosphere. This early atmosphere was toxic by modern standards, but it laid the groundwork for future developments. One of the most significant changes to Earth's surface came with the cooling of water vapor in the atmosphere. As temperatures dropped, rain began to fall, and the first oceans formed. These early bodies of water were likely shallow and acidic, and the sky would have been a hazy, reddish color due to the high levels of carbon dioxide in the atmosphere. Still, the formation of oceans marked a crucial turning point in Earth's history. Water, essential for life as we know it, was now present in large quantities. Around 3.8 billion years ago, during the Archean Aeon, life made its first appearance on Earth. The exact details of how life began remain one of the great mysteries of science, but it likely started in the oceans, where simple molecules combined to form more complex organic compounds. Over time, these compounds assembled into the first living organisms, primitive, single-celled life forms called prokaryotes. These early organisms were anaerobic, meaning they did not require oxygen to survive, which was fortunate because Earth's atmosphere at the time was still largely devoid of oxygen. For hundreds of millions of years, life on Earth remained microscopic and relatively simple. But even in this simplicity, profound changes were underway. Some of the earliest life forms developed the ability to perform photosynthesis, a process by which they could convert sunlight into energy, using carbon dioxide and water, and releasing oxygen as a byproduct. These photosynthetic organisms, known as cyanobacteria, played a critical role in one of the most significant events in Earth's history, the Great Oxygenation Event. As cyanobacteria flourished in the oceans, they released increasing amounts of oxygen into the atmosphere. At first, this oxygen reacted with iron in the oceans, creating vast deposits of iron oxide, which would later become the iron ore we mine today. But eventually, the supply of iron was exhausted, and oxygen began to accumulate in the atmosphere. This buildup of oxygen, which took place around 2.4 billion years ago, dramatically altered the composition of Earth's atmosphere and paved the way for more complex life forms to evolve. The oxygenation of Earth's atmosphere had both positive and negative effects. On the one hand, it made aerobic respiration possible, allowing organisms to use oxygen to produce energy much more efficiently than anaerobic processes. This led to the evolution of more complex, multicellular organisms. On the other hand, the sudden increase in oxygen levels was toxic to many of the anaerobic organisms that had dominated the planet up until that point, leading to widespread extinctions. This event, sometimes called the oxygen catastrophe, was the first of several mass extinction events that would punctuate Earth's history. With oxygen levels rising and the planet's surface continuing to cool, Earth entered a period of relative stability. Over the next billion years, during the Proterozoic Eon, life became increasingly complex. The first eukaryotic cells, which contain a nucleus and other specialized structures, appeared. These cells would eventually give rise to all complex life, including plants, animals, and fungi. During this time, the first supercontinents also formed and broke apart, as the process of plate tectonics began to shape Earth's surface. One of the most significant geological events of the Proterozoic Eon was the formation of the supercontinent Rodinia, around 1.1 billion years ago. Rodinia was a massive landmass that included most of Earth's continents. Its formation had a profound impact on the planet's climate, ocean circulation, and the evolution of life. But Rodinia did not last forever. Around 750 million years ago, it began to break apart, triggering a series of climatic changes that would lead to one of the most extreme ice ages in Earth's history. This period, known as Snowball Earth, saw the planet's surface covered in ice from pole to equator. The exact cause of this global freeze is still debated, but it may have been related to changes in ocean circulation or volcanic activity. For millions of years, Earth was a frozen wasteland, with glaciers extending across the continents and oceans covered in thick ice. Despite these harsh conditions, life managed to survive, likely in pockets of open water near volcanic vents or under the ice. When Snowball Earth finally ended, around 635 million years ago, the planet underwent a dramatic transformation. The melting ice released massive amounts of nutrients into the oceans, spurring an explosion of life. This period, known as the Ediacaran period, saw the rise of the first large, complex organisms. These early animals were soft-bodied and bore little resemblance to the creatures we see today, but they represented a major step forward in the evolution of life on Earth. The Ediacaran period was followed by the Cambrian explosion, a period of rapid diversification that began around 541 million years ago. During this time, nearly all of the major animal groups that exist today, arthropods, mollusks, vertebrates, and more, first appeared in the fossil record. The Cambrian explosion marked the beginning of the Phanerozoic Eon, the current eon in Earth's history, which is characterized by the abundance of complex, multicellular life. As life continued to evolve, Earth itself remained in a state of constant change. The continents, driven by the forces of plate tectonics, continued to move and collide, forming new mountain ranges and ocean basins. Around 300 million years ago, during the late Paleozoic era, the continents came together once again to form another supercontinent, Pangaea. The formation of Pangaea had a profound impact on the planet's climate and ecosystems, leading to the development of vast deserts and the spread of reptiles and early dinosaurs. But like all supercontinents before it, Pangaea eventually began to break apart, around 200 million years ago, during the Mesozoic era. As the continents drifted apart, new oceans formed, and the climate became warmer and more humid. This era is often referred to as the Age of Dinosaurs because of the dominance of these giant reptiles. Dinosaurs ruled the Earth for more than 160 million years, evolving into a wide variety of species, from the massive, long-necked sauropods to the fearsome predators like Tyrannosaurus rex. However, the reign of the dinosaurs came to a sudden and catastrophic end around 66 million years ago, when a massive asteroid struck the Earth near what is now the Yucatan Peninsula in Mexico. The impact triggered a series of devastating events, including wildfires, tsunamis, and a nuclear winter caused by the dust and debris thrown into the atmosphere. This mass extinction event, known as the Cretaceous-Paleogene extinction, wiped out nearly 75% of all species on Earth, including the non-avian dinosaurs. In the aftermath of the extinction, mammals, which had been small and relatively insignificant during the age of the dinosaurs, began to thrive and diversify. Over the next 66 million years, mammals evolved into a wide range of forms, including the ancestors of humans. Around 2.5 million years ago, during the Pleistocene epoch, the first members of the genus Homo appeared in Africa. These early humans would eventually migrate out of Africa, spreading across the globe and developing the complex societies and cultures that we see today. Throughout this long and complex history, Earth has been shaped by countless forces, both internal and external. From the violent collisions that formed the planet to the slow, steady movements of its tectonic plates, from the rise and fall of supercontinents to the evolution of life and all its diversity, Earth's story is one of constant change and adaptation. Today, we are living in the Anthropocene, a new epoch defined by the significant impact that humans have had on the planet. Our actions, through industry, agriculture, and urbanization, are reshaping Earth's ecosystems, altering its climate, and causing the extinction of species at an unprecedented rate. The history of Earth is still being written, and we are now a part of that story. In the grand scheme of things, human history is but a blink of an eye compared to the billions of years that Earth has existed. Yet, in this brief time, we have become one of the most influential forces on the planet. Understanding the history of Earth helps us appreciate the fragile balance of forces that sustain life and reminds us of our responsibility to protect this planet for future generations.